284 juniors at Central High School. We got a two-way frequency table. Let's just start answering the questions. I'm going to assume you've read this problem. I'm going to assume you've done some thinking. If you haven't, pause the video, read the problem, try a few on your own, and then come back to the video. Because this is just going to be the answers. I'm not going to reteach the whole topic. Okay, I'm going to assume you paused. Moving on. Find the probability that someone selected at random is a student volunteer, or that a student volunteers. Well, we have our total peoples, 284. And then of those 284, we have 185 total volunteers. Right. So I want to point something out. If they do not tell you that it should be out of people with a job or out of people without a job, anytime it's not conditional, you always assume you're using that total as your denominator. So find the probability that a student volunteers and has a job. So our total is still everybody at the school, but instead of just counting the volunteers or the people with a job, they got to be in both categories. So we have our volunteers and our job people, and we specifically see that there's 75 people that count in both categories. Find the probability a student has a job. Well, once again, it doesn't tell us to limit our total, so we know it's out of 284. And then our probability is just going to be all of our people with a job. And we look, there's actually 125 people that have a job. Some of them volunteer and some of them don't, but that's not relevant for this question. It's just that 125 total. Find the probability that a student volunteers or has a job. So we're going to use that addition rule from the previous page. We're going to take our probability for student volunteers and our probability for having a job. So our 185 over 284 plus our 125 out of 284. But some people both volunteer and have a job, so they're counted in both categories. Sorry, I accidentally wrote an equal symbol. Some people volunteer and they have a job, so they were counted twice. And actually, we already know from Part B, it's 75 people that are both volunteering and having a job. So those are our double voters, or our people that were counted twice. So we need to subtract 75 votes to make up for that. And we'll get our new probability. And it's 235 out of 284 people. So most people at this school are either volunteering or having a job, right? 235 out of 284. Some people are doing both, right? But most people don't think that they have enough time to do both things, so they do one or the other. E and F are going to be conditional probabilities. It may be hard to see, but there's a slash mark in the middle of what's in parentheses here. That's that conditional symbol. It's a little bit harder to notice when there's words instead of just A and B written. But let's read what this says. It says the probability of a student volunteers given that they have a job, or as I like to say, we can use that word narrow it down to. Probability that student volunteers if we narrow it down to who has a job. So let's narrow it down to who has a job. How many job holding people are there? There are 125. So another good trick is to remember what comes second, that's like our new denominator. And then if we narrow it down to those 125, of those people, 75 of them are volunteers. So remember, we can think this is who we narrow it down to. We narrow it down to the 125 that have a job. Here, we're going to find the probability a student has a job given they volunteer, or if we narrow it down to these 185 volunteers. Of those 185 volunteers, 75 of them have a job. And it's not a coincidence that 75 is used in both, right? These are the people that do both. We know 75 belong to each category. But anyhow, that's writing probabilities using a two-way frequency table. Couple of important things to remember. Here we have the addition rule for non-mutually exclusive events. Probability of one plus probability of the other minus the overlap or minus the probability that somebody does both. And that will give us the probability that someone volunteers or has a job. Remember, this is a calculation we do when we see that word or. Be sure to click the next video. I believe the next questions are on the multiplication rule for independent events.